I'm going to get this started now. I just got a couple slides to share with you to welcome you to this North American Phenology Campaign webinar. We have Dr. Liz Burakowski with us tonight. I should say I'm Alicia Carlson with the United States Globe and North American Regional Office. I'm the outreach lead for our office. I work with Jen Bourgeot and Haley Wickline, who's with us tonight. Haley's going to be helping out with popping links into the chat box and that sort of thing. But let's see. So I think most of you probably heard about this webinar through the Phenology campaign. But if you're not familiar with, there we go. With the campaign, right now we're measuring green up in North America. The Phenology campaign, though, we do in both the fall and the spring. So in the fall, we measure green down. And we're doing this to collect as much data as we can to focus on monitoring and reporting the phenology data to contribute to Globe's long-term environmental record. So green up measures bud bursts and leaf growth, and green down measures the changing colors in the fall. And it's just a really fun way to get out and observe our trees. There we go. So we're having webinars like this one for both educators and students and learners. And we'll have other resources to share with you throughout the campaign and opportunities for you to share your research. If you're in a school or another organization, we want to hear from everybody and see how things are going in your neck of the woods. So you can join the Phenology campaign. We're still accepting people. We love having everybody join us. And so Haley put the link in the chat there. But now, for the reason we're here, I'm gonna turn it over to Liz. I'll stop sharing and she can start. So Liz Burakowski is a research faculty member in the Institute for the Study of Earth, Oceans, and Space at the University of New Hampshire. Her research focuses on winter in the northeastern United States, including what changes we've seen in the past, what we can expect for the future, and the impacts, that's a crazy screen, the impacts on ecosystems and society. Dr. Burakowski is also a member of GLOBE and has worked with GLOBE educators and students in collecting data to study the transition from winter to the growing season. This all worked fine before you all got on. So let's just see if Liz can straighten out her screen. That's better. We're getting there, Liz. You're still muted, by the way.
There we go. Finally got it. Okay. Well, thank you, everyone. And thank you so much, Alicia and Haley, for inviting me to talk a little bit more about our research with phenology. So phenology, as you might know, is the study of seasonal cycles in nature. We're undergoing a big change right now as we work our way into spring. And as a scientist, we use phenology to understand how living things respond to these environmental changes. And as we see warmer seasons, we might see the shift in the timing of such cycles. And potentially that could lead to some mismatches that impact our food webs, the water cycle, the carbon cycle as examples. One of my favorite records of phenology that I know about is the record of the Kyoto cherry blossoms. So for more than 1,000 years, emperors, aristocrats, governors, and monks have been chronicling these flower dates of Japan's famed cherry trees in the city of Kyoto. But those bloom dates have shifted radically earlier in recent decades as a sign of a warming climate. And we can look at this data that they so diligently collected as community scientists. And when you look at this graph, what you're looking at is the day of year of the bloom date on the y-axis, and then the year over here on the x-axis. So this goes back to the year 812, which is phenomenal. And here's 2023 as the most recent. We can replace the dates on the y-axis with something a little bit more familiar. So the end of March is typically around day 90. Number of days past January 1st. So if we put March 31st here, April 10th, 20th, and April 30th, what we can see is that there's quite a shift here. Back in the year 1000 or so, it looks like the bloom date was closer to mid-April, April 15th. But recently, we've been seeing early dates. In 2021, we saw them bloom on March 26th. And in 2023, the record was broken and they bloomed on March 25th. So it's been a pretty remarkable shift by about over 2 weeks at this point. We can also look at how these shifts have been changing over time related to temperature. So if we look at the flowering day of the year, again, this is about the end of March, you're on day 90 to orient yourselves, getting up into April as you go up the y-axis. And we can ask ourselves what the average flowering day was when the temperature was about 4 degrees Celsius. So if you look over here and you look up here, it's typically around day 110 or 115. Going back to this graph, that tells you that it's probably around April 20th or so. So April 20th, when temperatures are colder, and beginning of end of March, when you start looking at temperatures when they're about 8 degrees C. So you can actually plot this up pretty nicely. So if you're collecting bud burst data over a longer period of time, another good variable to track would be your air temperature. So if you do the daily temperature protocol, you might actually be able to plot this up in a graph showing the flower date or the bloom bud burst date with the temperature. And it could be monthly temperature, it could be a weekly temperature, whatever you want to end up doing. So what are the impacts of this? Well, one of the things that we worry about is the mismatched timing between those bloom dates and the hungry and or wonderful pollinators that are contributing to the wonderful fruit that we all love to eat from these trees. So cherry trees, they do rely on pollinators. And if you have an early bloom date and then a sudden cold snap, you might find that the pollinators are no longer able to pollinate those cherry trees. And you start seeing a decrease in the crop yield. And this could be the crop yield for humans. I know I myself, I really love to eat cherries, but it could also be really important for birds as well. And so you see this cascading breakdown of the food web that could be all pinned on the timing of these important seasonal shifts, such as bud burst date, and your bloom date for very important fruits. Now, here in the Northeast, we don't have a huge cherry crop that comes about from our landscape, but we still do worry about what's known as the vernal window. So the vernal window, we call this the transitional shoulder season. We've essentially just about entered it today. We had a lot of snow melt today. So the vernal window opens in the end of winter, beginning of spring, when the snow starts to melt. So snow starts to melt, that opens up the window. You start exposing soils, you start having a greater sun angle, and you start seeing sunlight pour onto the forest floor. That vernal window closes when the canopy closes. So if you ever think of going out into the forest in the northeastern United States or in any temperate forest, the canopy closure date is typically the day when you start seeing the leaves at their maximum, once they've reached that plateau of maximum size, and you can no longer see the sunlight through the canopy. So things have gotten much bigger and you start seeing a lot more shade. This in turn affects how much energy is coming into the forest floor as well. So that we've been tracking this for a long time. Peter Groffman up at Hubbard Brook published a paper back in 2012 looking at the day of year when the snowpack disappeared. So again, we're looking at that y-axis. This is the date of snowpack disappearance. So day 90 right here to orient yourselves will be right around March, end of March, and moving upward into there, you getting into April and into May. So if we plot this in terms of actual dates, that end of the time series, right around 1950, I think it was 56 or 58, in the 1950s, they were seeing snowpack disappear towards the end of April. And today, this is actually only goes till 2010 or so. If you were to extend it, it actually does continue downward in the trend. We actually see snowpack disappearing in early April. So it's been a full shift of about 2 weeks, meaning our snowpacks up in the northern parts of the White Mountains are disappearing on average about 2 weeks earlier than they did in the 1950s. We can also look at that date of canopy closure. When we look at the date of canopy closures, this is the same graph, but now we're showing the canopy closure date at the top here. So when our phenology green up has concluded and we have full-size leaves, that has typically occurred around Memorial Day, May 28th, when we look at the 1950s. But today, it's closer to the mid-May 21st. So that's been about a week-long shift. So in terms of the vernal window, remember that's defined as that change between snow melt to canopy closure. We've actually seen an overall lengthening of the vernal window by about 8 days, because these two things are not happening at the same rate. Snowpack's being lost at a rate of about 2 weeks over these decades, whereas the vernal window closure date, the canopy closure, has been only about a week advancement. So it's been an overall lengthening of this period of time when we have a bunch of light pouring into the canopy, but we don't have any snow on the ground. That's lengthened by about 8 days. Another way you might think about this is maybe as mud season and dirt season, so when it's not quite yet green. I, for one, mud season is my least favorite season of the year. So having it lengthening mud season is not what I would like to see. I'd much prefer to keep our snow on the ground. Now, one of the questions I like to ask myself as a scientist is also what's the vernal window going to look like in the future? This particular winter happened to be a pretty cold and snowy one, but we also just reached 50 degrees today. So our snowpack is rapidly disappearing. What you can't tell by looking at this photo that I took on February 26th in 2017 is that I was wearing shorts and a t-shirt. This was at the end of February, and the temperature got up to about 70 degrees on that day. We did end up getting a little bit more snow after this photo was taken, but it was a pretty big shock to the system to think that our vernal window might have been extended by quite a bit if we lost all our snow in February. So historically, when I look at this using a climate model, I can calculate the date of snowpack disappearance in my climate models, and then I can calculate the canopy date for my climate models. And what I see is that in the 1980 to 2005 historical period, so when I was growing up in New Hampshire and when I was in college, that was looking like a vernal window of about 46 days when you average it over the entire northeastern United States. And you can see some cool patterns here. What we know is that the vernal window is much longer in the southern part of the region, and it's a bit shorter as you get further north and at higher elevations, which makes sense. It takes longer for snow to melt up there, and you typically have a longer period of time before you end up in the warmer spring season. And so before all y'all got on, Alicia and I were talking about how she lives in the banana belt of Vermont, also known as the Champlain Valley, where it's a bit warmer than the rest of the surrounding area. And so Alicia is expecting to see her bud burst come a little bit earlier than the rest of us. And thus she probably has a longer vernal window where she lives compared to where someone might live if they live at a higher elevation, say in the White Mountains or in northern Maine. So what happens in the future? Well, if we continued with current climate policies, and this study was actually done back in 2020, so it was about climate policies roughly around 2020, what we see is a lengthening of the vernal window. And if you train your eyes, you can also see that the snowpack, so the area where there even is a vernal window, that has also retreated. So we see a retreating of our snowpack's lost earlier, and we also see earlier bud bursts, but similar to that pattern at Hubbard Brook, it's not occurring at the same rate. So you see an overall lengthening of the areas that have a vernal window by about 60 days. So it ends up being 60 days. So it's a lengthening of about 2 weeks. So that 2 weeks that we've seen since the 1950s, by the end of the century, we'll add another 2 weeks onto that. If we look at a more dire climate scenario, so the trajectory that we were on prior to the signing of the Paris Agreement in 2015, we would have ended up looking at a vernal window similar to this. So you can see coastal Maine sees a vernal window that's exceptionally long. You're up into the 70-day mark here in Maine, and only the highest elevations are retaining those long vernal windows. Those are the ones that retain snowpack longer. So we know that these vernal window changes are important, and it's important to track them. And that's why we're really interested in having GLOBE collect data, because this gives us some more points of data that are relevant to how snow is changing and how our ecosystems are responding. One of the ways we think about this is in terms of the energy balance. So when you are losing snow, you're rapidly shifting the amount of energy in the ecosystem. Snow is a great reflector, reflects a lot of the sun's energy. And once you get into a snow-free state, now the ecosystem is absorbing more of that energy and things start to warm up really quickly. We also think about the carbon cycle. When you see an earlier or longer vernal window, that means it's a longer period of time until bud burst, meaning soils can warm up and they'll start respiring organic matter. So this is that decay process that's going to produce carbon dioxide and move it into the atmosphere. Once the canopy bursts later in the spring, then we start seeing photosynthesis happen. And some of the research that we've seen is that the trees are much slower to respond to this change in the vernal window length compared to something like a grassland. So if you're looking at green up of grasses, you've probably noticed that your lawn greens up quite a bit quicker and is much more responsive to warm temperatures than, say, the forest in your backyard. We also worry a bit about peak stream flow. Stream flow is really important for delivering nutrients into our aquatic ecosystems. And when that timing of peak stream flow gets mismatched with the snow melt, if that's occurring earlier in the year, and say, for example, the nutrients that are necessary for the nurseries in the Great Bay that are supporting our fish habitat, so our fish nurseries, then you also see this mismatch that can occur. So the timing of peak stream flow is also important. And one of the things that I've done with some high school students across the region is to look at this in terms of how they conceptualize the timing of events during the vernal window. And some of them they're probably pretty familiar with. They know when snowpack disappears. That's usually evident as you're walking around the playground, or if you're trying to get to school, you'll notice that there's a period of time when the snow is melting and then you get to a snow-free state. They might also notice that change in bud burst. Maybe if they have soil frost tubes, they might also notice soil thaw. So when is that happening? And then we can also see when our rivers are raging. If you drive over bridges, you might see the rivers and stream flow going very quickly, or you might also see ice out. So when our popular ponds and lakes and bodies of water in our communities start to ice out. All of these are the indication that you're transitioning through that vernal window. And what we can do is have students assemble these into a timeline in a hypothesized order of the events, and then discuss how each of those different events is related to energy, water, or maybe even carbon. And so then they can also do the measurements. So if you're collecting globe protocol measurements, such as snow depth, soil frost, canopy green up, you can start to assemble these into a timeline. And if you wanted, you could also throw in those water ones, such as the stream flow and ice out. And when you do that, you can end up with an anticipated timeline. So if this is one from an example that we did, I believe this was up in Old Town. So starting with January 1st and then progressing to May 31st, this was their hypothesized timeline. They then collected their globe protocol data through snowpack depth, soil frost depth, and canopy green up, and they were able to compare and revisit their hypothesis. And this particular year, they were actually pretty spot on with their snow disappearance date, which was pretty validating for them. They were going off of their lived experience of like, I think the snow might disappear around mid-April, and they were only 2 days off on that one. So well done. They also looked at bud burst, and in this one, they were actually off by a whole month. And they thought about why that might be. Why did they think that it was happening later versus earlier? And some of this was a bit of maybe thinking about other plants that had been flowering in April. Some of them were also surprised that it was so late in that particular year. And then, of course, canopy closure as well. So they continued measuring their leaves right up until the end of their term. And their observed date was June 2nd. So right around that Memorial Day weekend there, which was quite a bit earlier as well. What they also were able to do is pass this information on to the next class. So the next year, when students made their hypothesized timeline, they also had a little bit of data to go on in terms of what the previous groups had seen. And when we can do that, we can also just compare the timelines for different years. So for this particular event, 2019, they had guessed April 18th for their snow disappearance date. And they had found that in 2020, it was actually quite a bit earlier. It happened in early April. So the snowpack they found was a bit flexible. That one tended to move around quite a bit. But what they saw with the bud burst and canopy closures, that those were actually a little bit more consistent. You found that we actually had some pretty similar dates there. They were also able to plot up their data against air temperature. So looking at different types of forests as well. For example, they had a coniferous forest that they were tracking. Those are the gray square, the black squares here. And then also the deciduous forest in gray here. And they were able to say that the temperature, when it's warmer, you do see a longer vernal window, which was consistent with the hypothesis and what we had learned about. They also were able to compare this to other high schools. I didn't actually get the data from Newport, Dover, and Portsmouth, but Bishop Girton reported a vernal window length of 64 days in their southern location in southern Vermont, New Hampshire here. And then Old Town, again, consistent with what we observe, they found that their vernal window was substantially shorter. It was on 45 days, so about 3 weeks shorter up there. And with that, I will conclude and just say that there are tons of opportunities for globe protocols. I've just listed a couple here, but there's also the water temperature protocol. So if you have a body of water near you, you could do that one. Soil temperature is another great one for tracking soil thaw. And then you can also think about what type of research questions your class might answer about the vernal window and that seasonal transition. Maybe it's something that's they track over time, or maybe it's something of community relevance, such as power to the hydro dam or something that is in their community. So with that, I will conclude. I will note that we wrote a paper on that timeline activity. So if you're more interested in it, I'm happy to send it to Haley and Alicia to distribute. But it's a fun little activity that students can do for some hypothesis testing. All right, and with that, I say thank you, and I have plenty of time for questions.
That was great. Thanks, Liz. So folks, if you have questions for Liz, you can type them in the chat. I have a question about, so the Bishop Guertin data, did you have were those students in contact with the Old Town students, or was that data that you pulled from somewhere?
The teachers, I believe, had met. The students themselves, I don't think got a chance to Zoom call, but that would have been a great opportunity to have them talk with the other students. We did share the data with the respective classrooms. So Old Town knew that Bishop Guertin had a longer vernal window and vice versa.
That's interesting. Thank you. Anybody have anything they are dying to ask Liz while she's here? You know, she was on the Boston News Channel recently, so she's going to be famous pretty soon, and you may not have another chance to ask her directly. So,
thanks, Alicia.
Tina, go ahead.
So I have a question. In my yard, I have always tried to leave the leaf debris to a reasonable amount so that all through the winter there is sufficient amount for pollinators or whatever might be in the soil. So if things are warming up, budding sooner, is there a timeline in which that should be removed sooner or left for the same length of time as I have in the past?
Ooh, that's a great question. And I don't think I'm the expert on pollinators to say this, but what I've learned from co-op extension, I believe it was to wait at least 5 days of like 60 degrees temperatures, or when you actually start seeing some insect activity in your yard, give it like another 5 days after you've seen that. But I would defer to pollinator experts on that one.
Okay.
But I'm a big fan of leave the leaves as well. Although the voles, boy, they found they actually
Yes.
exploded in one of my beds. So that particular one, I'm a bit more diligent about.
Well, not all the neighbors were happy, but it made me happy.
Yeah.
Neighbors are hard to keep happy, I find. Anybody else have a question or a comment? Peter, go ahead.
Oh, you're still muted.
Still muted.
Hello.
There we go. Yay.
Okay, great. Yeah. So that vernal window, that really is that section where all the understory plants can grow and flower.
Yeah.
But the fact that it gets extended, that means they flower at different times. Like would be only be a concentrated flowering, which is good for insects, the pollinators, basically. But by extending it, is there any stories on impacts on that?
Yeah, so there's actually a great project up at Appalachian Mountain Club where they're asking folks to track the bloom dates of those alpine ephemerals. So the ones that are blooming during a certain period of time. And they are studying that. I don't know if I've actually seen any papers on it, but they are interested in how that is shifting. In terms of the actual research on the insects, I'm not 100% sure on the impacts on, say, like our local like Trillium and such, but I think that there is potential for those mismatches with the insects if they're blooming longer or shorter. The other one that I worry a lot about is invasives. So invasive species such as Japanese barberry, Himalayan blackberry, they tend to have an edge over native plants that are typically responding a bit more slowly to those changes in temperature. And those other plants that are like the Japanese barberry in particular, Himalayan blackberry, and then also burning bush, those ones I've also noticed they green up a lot quicker and they tend to get a competitive advantage over the plants that might be a little bit slower to respond to those changes in temperature. So a lengthening vernal window could potentially mean that you also see a spread of the plants that do take advantage of that open canopy.
Okay, and I hadn't thought about the barberry. Yeah, like that we have a big invasive problem in Queens and Manhattan of the barberry, and yeah, that extra window of time would just, just gives them a, because they're the first ones up. They really
Yep.
are usually the first ones up.
Yep.
And yep. Nasty, nasty.
Yep.
Thank you.
Welcome.
I do love the spring ephemerals, so that's a highlight of living in the banana belt of Vermont. All the pretty little woodland plants that pop up. I see Tina said she loves the examples that you provided on the different globe data that can be collected to measure the vernal window. And I love that too. So I think if Liz shares that, this activity with Haley and I, we can share it out through the Phenology campaign email. You have to sign up for the Phenology campaign to get the email. So that's your little nugget to get this this activity. So any other questions? We still have a minute with Liz here.
I have a question. So I was just thinking about snow melt, and well, one is when you determine snow free is like no snow visible. Is that the kind of the bar?
Yes, snow free is visible, and it's the last time before the onset of snow in the fall as well. So it's a retrospective, like the snow disappeared state. Sometimes it can throw you a curveball, like it disappears and then it comes back.
Right. So I'm just curious for your research, how frequently you're going out and checking and measuring that, because it can happen so fast.
Yes. Yeah, we do daily measurements here at the University of New Hampshire. So that means that we have several undergraduates and graduate students that are rotating through. We don't have the same person going out every single day, but a daily measurement can capture that quick warm up and figure out when that happens, because it can be within a day.
You know, with the students you worked with, were they able to do, I mean, that's hard. They're not there on the weekend, or, just what, is there some like, if I were to do that with students, like, is there some give there?
Yeah, I mean, it will affect the accuracy. So you can say that the snowpack disappeared on or about April 20th, plus or minus 3 days, something like that. And so there'll be a little bit of wiggle room, and then that gets added on to the length of your vernal window. So for example, if you're not tracking bud burst every single day as well, similarly, that bud burst might happen on a day that you're not measuring, and then the day you come back, it's there. So it just adds a little bit of uncertainty, but overall, given that the vernal window length is about, ranges from like a month to 2 months, having a couple days at the end of each is probably perfectly fine, and you'll still be able to see those changes over time. But more frequent, the better.
Yeah, collect that data. Okay, well, I think we've come to the end of our time here, so I want to really thank Dr. Liz Burakowski for joining us for our Phenology campaign webinar. So thanks everyone for joining us tonight, and here comes
Thanks,
spring.
everyone.